Be nice. Okay, here we go. Our objective for today, I can solve and graph compound one variable inequalities. We read it together. 1, 2, 3. I can solve and graph compound one variable inequalities. All right, can you read it by yourself, Priscilla? Go. Thank you. All right, so we're on the same concept, one variable inequalities, but today we're looking at a special type of inequality called compound. Let's find out what is so special about it. We don't need the Ferrier model because we already know what one variable inequalities are. We don't need the steps because we know that our steps are to simplify, isolate, plot, and check. Have we been doing that? Yeah, even the homework's been asking you to check on some of them, right? All right, so check this out. So, with that said, at this point, I want you to put your pens down and pay attention. I want to make sure that you understand what we're looking at today. Okay, here we go. Focus, please. So, we already have covered these kind. Everybody look up to the screen, please. Here it goes. To solve this kind of inequality, I know that I cannot simplify any of the two sides. It's already simplified. I need to isolate the variable. Therefore, I subtract 1 from each side. Are we there so far? This leaves us with -6 less than x. Therefore, if I was to graph this, we got 0, we got -6. Is it including the point? No, it's open point, and we read it. What -6 is less than x? What numbers can I substitute for x that -6 will be less than those numbers? So let's see. Here's -6. -6 is less than which numbers? All the numbers to the right. That's why we highlight that one. Are we there so far? Okay, let me show you another one. Let's say I gave you this one. Steps. Can I simplify this side? No. This side? No. Therefore, I isolate the variable. I subtract 1 from each side. That leaves us with x less than 1. Are we there so far? To graph that, here's my graph. I got 1 right here. Does it include a point? No. Circle the point. There it is. And then x is less than 1. What numbers are less than 1? Anything to the left. Are we there so far? Okay. Now check this out. Here it goes. So, at this point, we already know how to do these. Today, what they're going to do, they're going to combine two inequalities into one. So for those of you that are still a little bit shaky on the inequalities because you haven't been practicing, today they're going to increase the little rigor bar. Here it goes. Check this out. When we combine two of them together, the word combine means compound. You've seen that in science. Is that correct? Compound means to combine. So check this out. I'm going to combine these two so you can see how this works. Focus, please. Watch. Look at this one. I'm going to move this over, and I'm going to combine it with this one. And now it became 1. This is what we call, check this out. This one is what we call compound inequality. Now let me show you all the components so you guys can see where everything comes from. Check this out. Now that I did that, now you can see that here, look at this one. This one has x plus 1. This one also has x plus 1. Therefore, when I combine the two, these two overlap. That's why it's only written 1. Do you guys see that? Yes. Okay. But look at the graph. This one was pointing to the right. This one was pointing to the left. But don't they both intersect right here? That would be the solution set for the compound inequality. Everybody see that? All right. That was an introduction. I'm going to show you how to solve these. Okay. So copy this next example. Example 1. It says, solve the compound inequality and graph the solutions. -5 less than x plus 1 less than 2. Have your pens handy because this is where we're going to use the different colors. Here it goes. Focus, please. Please stay focused or else you're going to miss this. Here it goes. I'm going to use two colors. I'm going to use red for this side of the inequality, and I'm going to use green for this side of the inequality. Okay? So check this out. Right now you're not copying, you're just paying attention. Here it goes. First of all, if I was to only have one inequality and I covered this piece, do we know how to solve this? Yes, I would do what? Minus 1, minus 1. However, if I was to cover this piece, what would I do? Minus 1, minus 1. So therefore, from now on, if we see that it's a compound, we do that one step to everything. Minus 1, and minus 1. This becomes negative 6 less than x less than 1. Copy that, please. So to graph this, I would get my number line. Here it is. You're just paying attention. Here it goes. Here's 0. We have negative 6, and the other one is 1. Oh. 1. Okay? So for this piece, I'm going to graph this in red. So I'm going to box this so I can just look at this inequality. Negative 6 is less than x. Does it include negative 6? No. Negative 6 is less than any number that I substitute in here. So by looking at it, negative 6 is less than which numbers? The ones on the left or the ones on the right? To the right. Negative 6 is less than all these numbers. Okay? I'm going to box this second part in green. So it says x is less than 1. Does it include 1? No. X is less than 1. What numbers are less than 1? Everything to the left. Do you see how both graphs intersect right here? This is what we call compound inequality, but this is known as the AND inequality. Why? Because for the solution set, we need these and that. But since they both intersect, so basically our solution set will be from here to here. Let me show you. Here's a solution set. Solution set for all x such that, and then I just write whatever I ended up as my compound. Negative 6 less than x less than 1, and I'm done to right there. Copy that, please. So the question was, do we always leave the x right here in between the two inequality symbols? Yes, because that tells us that our x values should be between negative 6 and 1. So let me show you how that works. Check. I'm going to check with blue. I'm going to rewrite our first and original inequality. Negative 5 less than, instead of x, I'm going to open up parentheses, plus 1 less than 2. So what we're saying is that the solution for this inequality is found in here. What would be the easiest number to think of to substitute to check? 0. Let's see. Negative 5 less than, what is 0 plus 1? 1 less than 2. So therefore, we're going to read it from left to right, and if it's true all the way, therefore our solution is found in it. Let's see. Negative 5. Is negative 5 less than 1? Is 1 less than 2? Yes, therefore our solution is found in between negative 6 and 1. Copy that, please.
Oh my God.
All right, copy this next one down. Example 2. Example 2. 8 less than 3x minus 1 less than or equal to 11. Let's do this one together. Once again, I'm going to draw a red line down this way and a green line down this way so I know that I'm going to use two different colors to graph. So let's see. By looking at it, let's see. If I was to cover this with my hand, let's see, this, what do I need to do to that? Add 1 to each side, therefore I need to add 1 to everything. This becomes 9 less than 3x less than or equal to 12. By looking at it again, Is the x by itself already? No. What do we need to do?
Divide by 3.
Divide by 3 everything. We're left with 3 less than x less than or equal to 4. Are we there so far? Okay, let's graph it. Good.
What do you mean?
0. This is 3, and this is 4. However, I'm going to box the first part with red, so I can graph this in red. So let's see. This is 3 is less than x. Does it include the 3? No. It's an open circle. Okay. 3 is less than x. What could x be that 3 is less than? So what numbers should I shade that 3 is less than those numbers? Everything to the right. Look at this one. The second part. I'm going to box this one in green. X is less than or equal to 4. Does it include 4? Yes. Solid points. What numbers are less than 4? Everything to the left. So, do we have both graphs intersecting? Yes, this is known as and. Let me write my solution set. Solution set for all x's such that 3 is less than x, less than or equal to 4. All right, let's check this. Right, check. And you write your original inequality, which is 8 less than 3, open parentheses, minus 1, less than or equal to 11. Now think about this question. I'm going to ask you to check our solution set. What numbers can I substitute in here to check that are part of my solution set? Think about it. Okay. So you're thinking of a number that's in between 3 and 4. So basically it's going to be a decimal, right? Or a fraction. However, do you guys see that the 4 is a solid point? So could I use 4? Yes, I can use 4. So I'm going to go ahead and use 4. Yes, the solid points means that that is included on the solution. Solid points, it means that it's included in the solution. Tell your neighbor what I just said. Okay, let's simplify this. This is 8 less than, what is 3 times 4? That's 12 minus 1, less than or equal to 11. 8 less than, what is 12 minus 1? That's 11, less than or equal to 11. Let's read that from left to right to see if it's true. Is 8 less than 11? Yes. Is 11 less than or equal to 11? Yes. Therefore, my solution set is in between. Yes. Everybody got it? All right, do this next one by yourself. Here we go. By now, you should be able to do these next two by yourself. Copy this one down. Example number 3. Negative 9 less than x minus 10 less than negative 5. Go. 30 seconds. Okay, here we go. So I'm going to draw my line down this inequality symbol and another line down this inequality symbol. So let's see. By looking at it, it means that we need to leave the x by itself. I add 10 to everything. Therefore, we're left with 1 less than x less than 5. Hands if you got that. Okay? Look at the graph. 0, 1, 5. Let me see. We'll do this part in red. Let's see. 1 is less than x. Does it include 1? No. 1 is less than any number I substitute for x. 1 is less than which numbers? The ones on the left or the ones on the right? Right. Therefore, I shade that. Then I box the second part. Does it include the 5? No. Okay. X is less than 5, so that's everything to the left. Do the two graphs overlap? Yes, if they do, this is an and. Therefore, my solution set is x such that 1 less than x less than 5. Hence, if you got all that by yourself, okay? And if I was to check it, let's see. I rewrite my original one, which means negative 9 less than x not x, parentheses. Parentheses minus 10 less than negative 5. So by looking at it, what number should I substitute to check? 4, 3, any of those numbers, right? How about a fraction, or a decimal? Yeah, let's try a decimal. I'm going to do 3.5. So we're left with negative 9 less than 3.5 minus 10, that's negative 6.5 less than negative 5. Let's see. Let's read it from left to right. Is negative 9 less than 6.5? Negative 6.5. Yes. Is negative 6.5 less than negative 5? Yes. Therefore, my solution set is true. Okay. Last one. Here we go. Of these kind. Copy this one. Negative 4 less than or equal to 3n plus 5 less than 11. Do that one by yourself. Go. 30 seconds. Okay, I'm going to draw 2 lines down, and I'm going to start by subtracting 5, subtracting 5, subtracting 5. We're left with negative 9 less than or equal to 3n less than 6. From there, divide by 3, divide by 3, divide by 3. Negative 3 less than or equal to n less than 2. From there, our graph, we got 0, I got negative 3, and I got 2. I'm going to graph this first part in red. It includes the point. Yes. Negative 3 is less than n. Negative 3 is less than which numbers? All the ones to the right. Okay. The second part. 2. Does it include it? No. N is less than that. Everything to the left. This is known as an and. My solution set, the set of all n such that negative 3 is less than or equal to n less than, not equal, that's just less than 2. Hands if you got that by yourself. Okay. And for this one, I'm not going to check. I'm going to move on because I need to get to the other ones. But you know how to check this, right? Yeah. Oh, let's find out. If it doesn't make an and, then it's one of these. Copy this one down, please. Copy this one. Example, what are we on? 5? 1, 2, 3, 4. 5. Example 5. Example 5. Copy that, please. It says 8 plus t greater than or equal to 7, or 8 plus t less than 2. Here we go. So I'm going to notice this one now, it's split up. It's no longer a compound in regards to the first ones we did. This is a different kind of compound. So I'm going to do the first one in red. So to solve this one here, I subtract 8, subtract 8. Therefore, I'm left with t greater than or equal to negative 1. Are we there so far? Or, we'll do this one in green. Subtract 8, subtract 8. T is less than negative 6. Are we there so far? To graph this, let's see. 0. I got negative 1 right here, negative 6 over here. So I'm going to do the red part first. This one, negative 1. Does it include the point? Yes. T is greater than negative 1. What numbers are greater than negative 1? Everything to the right. Oh, there it is. This one, open point because it's not an or equal to. T is less than that. What numbers are less than that? Everything to the left. What do you notice here? Does not intersect. That's why these are known as or compound inequalities. And let me explain the or. Let's say you went to the food court. Everybody look up. If you went to the food court with the and, this one, you would have, let's say, Mongolian food and Italian food. So some of you would like a rice bowl with something and then a slice of pizza. However, look at this one. This one says you're either going to have Mongolian or Italian. That means it could be one or the other. Could it be both? No, because they do not intersect. Everybody got it? That's why these are known as or. They're not intersecting. So therefore, my solution set, the set of all t such that, and I just write this, t is greater than or equal to -1 or t is less than -6. Copy that, please. Okay, let me check this so you can understand what the or means. Check. I'm going to write the original one, 8. 8 plus parentheses greater than or equal to 7, or 8 plus parentheses less than 2. So, check this out. What number do you want me to use to check this inequality? Look at it. What would be an easy number from here? 0. Okay, I'm going to use 0. Okay, so I'm going to substitute 0 here. 0 here and 0 here. So let's see. 8 plus 0 is 8 greater than or equal to 7, or 8 is less than 2. So let's see. Is 8 greater than or equal to 7? Yes. Or is 8 less than 2? No. But as long as one of them is true, that's what the or means. Are we there so far? Okay? That's how we check this. Hold on, before we go, pay attention to this next one. All right, check this out. Everybody look up. Now this one, they already gives us the solution in a graph. So all we have to do on this one is write our inequality. When they don't give us a variable that we can define, you can use any variable you want. I usually use my initial. That's why, if you notice, I use a lot the letter what? Q. So therefore, get used to, so like that, when they don't give you a defined formula, that you actually substitute the value of a variable with your initial. So check this out. So here, I'm going to use this one. Everybody look up. This one, the letter Q, represents all these numbers. And what is my dividing point? -8. Are we there so far? So look at it. What are these numbers compared to -8? Less than. However, is it a solid point? Yes. Okay. We're done with that one. So now I'm going to focus on this one. Q and 0. What are these numbers compared to 0? So greater than. Does it include the point? No. However, are these two graphs intersecting? No, this is known as an OR. In the solution set, all you have to do is write solution set of Q and that. So homework for tonight. Pay attention, please. What page is it? 174. Hold on. I didn't excuse her. Have a seat. 1 through 23 odd. Okay. And before we leave, I'll be at the door taking your homework. That's going to be your ticket out. Okay? So here we go. Have a good one, guys. Enjoy your homework. See you guys tomorrow.